New partnership and ecosystems happening. Just had a recent announcement, AT&T partnering with a company in Seattle we all know and love, Microsoft. Very interesting, right? Very powerful public cloud strategy and partnership for a major telco. That's a whole new set of services that they're going to be able to bring to market together. If you take a look at the middle bucket there, third largest MNO, mobile network operator in the world. I'm talking about Reliance Jio. Does everybody know what happened there? They went from 0 subscribers to 100 million subscribers in about 6 to 9 months. I don't think anybody could have told you that was even possible. That has not happened in the history of anything in this industry. They have over 300 million subscribers now. They are the third largest MNO in the world. Okay, very disruptive. You know what happened when they introduced their service? They gave it away for free. I'm always talking to mobile operators about the residential ARPU, and we're talking about it remaining flat. What if somebody came into your region and offered your connectivity for free? Forget about flat. You have a very different problem on your hands. Okay? Another one, virtualization and automated infrastructure. By this, I'm referring to a carrier in Japan. Okay, if you're familiar with the Rakuten network, there's a lot of really good press and white papers on that. They claim that by embracing automation, virtualization technologies, they can run their network at 50% or less the cost of a traditional network. Okay? So in my 23 years, I've actually never seen such a confluence of different things coming together at the same time. Sometimes we have new technologies that are pretty cool, but they don't necessarily solve a business problem. Sometimes we have business problems that don't have a matching set of technologies that we can use to go solve them. I'm actually telling you, we're actually at a point in time now and over the next several years where we actually have very interesting technologies to leverage and a real set of business requirements and imperatives. If we frame out the entire ecosystem, if you will, of the market, we're seeing any number of very interesting things that we have to pay attention to as we construct our networks. We have some very fun statements up here. Cloud is eating the world. The real metric behind that is 50% of enterprise applications are moving to the cloud by 2020. Like we're here, we're there already. We're already seeing that. Cybercrime, $6 trillion spent on fighting cybercrime. Economics, every operator feels this. The amount of bandwidth increases versus the investment they have to put in. It's pretty interesting, especially since their budgets for CapEx are typically flat, is what we're seeing. You're also seeing the expectations rise from people in terms of bandwidth and connectivity. Internet of Things, 75 billion connected devices, much faster speeds. We talked about that all throughout the day, required for 5G. AI, ML, and NLP, there's a whole bunch of new technologies I think that are being leveraged in business today as well, and we have to pay attention to those as we go forward. So let's talk about those services now. Okay, so traditionally you see a triangle. I think we created a circle up here for the traditional 5G set of services and how we've categorized them. So EMBB, what does that mean for your network? Functionally, it means a bandwidth increase. Okay. Now, if we're just doing 5G for bandwidth increases, it's not necessarily, I would say, a good business equation for people. If we look at residential ARPU for globally across the world, we're not seeing necessarily an increase happening from that space. What we are seeing is a difference on the enterprise side, the IoT side, investment by public sector. So if you look at the other two types of service types, massive machine type communications, especially around IoT. If you look at URLLC, ultra reliable low latency communication, that becomes very interesting as well. Okay, one of the top questions I get within talking to various CTOs globally is, hey, how do I actually make money to go and deliver my next set of services? What do you mean by 5G? I had one CTO tell me, I just finished paying off my 4G network. You're telling me I have to go invest again. So what do I need to do? There's a set of services up here on the right-hand side of the screen. These are actual sets of enterprise and public sector requirements that we have heard from service providers and enterprises of what they want to do on networks. One of the most interesting one that came to me was from a provider in Japan that said, hey, we have a car manufacturer that's come to us and said, we want a private slice of your 5G network. It's like, oh, fascinating, why? Well, it turns out, anybody have any ideas on how much code is on your car today? I started researching it. There's 10 to 100 million lines of code on your car. It's a connection of computer systems. This probably scared the heck out of some of you from a software bug perspective. It should, by the way. My father was actually driving in his minivan and the car stopped. Luckily, he didn't get hit. The most interesting thing he told me was, you know, Andrew, I was at the car dealership. They didn't replace a single part. They uploaded a new set of code that basically patched their bugs in their code. In fact, most of the bugs in cars today are actually fixed via software. So, hey, this becomes interesting in the automotive industry about getting a 5G slice with massive amounts of bandwidth to go and upload your cars. There's a whole host of other things. Telematics. How do they stream information off cars? So they can go put that in their data lake, run ML and AI algorithms to see how their system's performing. It becomes an interesting problem, right? Infotainment. How do you stream Netflix to your car so your kids stop asking if you're there yet, right? I mean, there's a whole set of interesting things the automotive industry, just one vertical, is looking at where operators should pay attention to, okay? Another one I heard, an SP in the US said, I have a public sector issue, or not issue, a request. It's actually a nice problem to solve. They wanted a network for first responders, ambulance, police, fire. They said, I will pay you extra if I have a super highly available network. It cannot go down. A super highly secure network cannot be hacked and broken into. I want that for my first responders to have better response time to our constituents. It's a real problem. It's actually something that's monetizable. Again, okay, there's a couple of different interesting ones here. I'll just skip to the last one. So a demo we actually did with some partners. Mobile SD-WAN enabled ambulance. So let's take the principles of SD-WAN, where we have multiple connections through a network. We're monitoring QoE on those connections, latency, jitter, different capabilities. In this case, we enabled an ambulance with a 5G slice, a 4G slice, and satellite backup. And we had the ability to basically choose how we kept the ambulance connected in this case. So my point goes back again, you know, Jacob's wise old words, follow the money. What are the next set of interesting applications you're going to actually derive on your network? They all start with the MBB, it's more bandwidth. That's great, it's more connectivity. It doesn't necessarily mean you're going to change your financial profile as an operator. Okay, so let's jump in. You're an operator. What do you need to look at in your network? It's actually super interesting. It could be super scary as well. And I'll kind of run through this. Network convergence. Are you building one network? Can you combine your mobile and your wireline network? Can you combine your business and residential services? Have you looked at your front haul? Are you packetizing it? We just talked about ROE. We just talked about eCPRI as technologies. How are you investing? Further back in your network, pre-ag, aggregation, core. Are you going to look at scale-out architectures as opposed to scale-up architectures? It's a fundamentally different paradigm in how you build your network. Next, edge telco cloud distribution. This becomes critical, especially as you're thinking about the next-gen set of services you're going to distribute out in your network. Some are very latency sensitive. Some will have certain QoE applications. You're already starting to see the data center distribution further out in the network, particularly in the States. What is your strategy? Cloud RAN, we just talked about that. Virtualized CU/DU, how are you doing that? What is your strategy for handling that? What's your network slicing strategy? We'll touch upon that today. Subscriber convergence. Are you going to actually move your wireline and wireless subscribers? Maybe have the same policy plane. Are you going to bring them in terms of an any access methodology and way of thinking in? And security. How the heck do you secure this network? We just talked about 75 billion IoT devices being connected. Every one of those is a threat surface at this point. So everybody should feel good that they all have this under control now. Not much to think about. The reality is this is scary, and you actually have to think about this holistically as you build out your network. Let's start at the top here and start looking at the IP transport. I wrote IP Transport Simplified. Let me explain what I mean by that. I really believe that your IP transport has to be simplified in terms of operations. I think to get there is anything but simple. Usually the engineering work that's required behind it, you really have to think through several different pieces. So let's start with the basics and kind of build on that in terms of what we're seeing as decision points as various operators across the world. So we talked about the bandwidth increase, and it cascades as you go up. We talked about moving from 1 to 10 gig. We're seeing RFPs across the board for 25 gig as connectivity as well. Seeing that globally. Further back in your network, what's your 100 gig, what's your 400 gig strategy in your IP core? All very critical decisions you have to make on the systems that you buy. Timing and latency, we talked about that. Are you Class C ready in terms of being capable of handling the timing and latency requirements in the network? This is very critical as well. Operational simplicity is another one. Now, this becomes interesting because what we're seeing now is actually a protocol evolution in the IP network. We see a lot of MPLS-based networks, layer 2 and layer 3. We're actually seeing an evolution towards segment routing. And I will say probably by 2020, 2021, 90% of the operators we're seeing globally will have some type of segment routing network in operation, to be candid. It might be SR MPLS-based. Japan, we're seeing a straight jump to SRv6. It really depends on where you are in your geo. But ubiquitously, we're seeing an underlay move to SR overall. EVPN, we're also seeing as an overlay strategy from a services perspective. So this goes back into high availability. Another reason we're seeing a move to EVPN overall from an L2 convergence perspective is it's leveraging BGP from a fast reroute, convergence perspective, active-active type of topologies as well. We talked about scale. Super important to think through logical scale on your network. If you're using 5G to go deliver various next-gen IoT applications, next-gen sensor applications, your endpoint scale is actually going up exponentially in this case. How do you handle the logical scale of your network is a very big consideration overall. So you can kind of see on this slide some of the things to think about. We talked a little bit about them earlier on some of the panels, 150 to 200 microsecond round-trip time in terms of the front haul, around a 10 millisecond round-trip time in terms of applications. How do you build it? You have to think about that pretty clearly. If we jump into network slicing, there'll be much more, I think, involved discussions as we go throughout the day. This is just one click down as we look at this. What the heck does this mean in terms of network slicing? Think of it as an end-to-end logical segmentation of the physical network based on a services profile. So on the left here, we have 3 profiles, EMBB, MMTC one with massive IoT, and then a URLLC one, which would be something where you think about like autonomous driving, et cetera, et cetera. Your slice actually needs to go through all layers of your network. Okay, with the access, the transport, the core, you should be thinking about your slice actually going through your telco cloud or your edge cloud pieces as well, and it can involve your radio, obviously, also. What we're seeing on the IP transport piece is we're seeing majority of implementations based upon segment routing. Okay. We see people using Flex Algo as their method to offer multiple slices in the network with segment routing. We also see people using an SRTE controller for controller-based segment routing implementations to go program the slices in the network. As far as scaling it out, 2 big protocols we're looking at is BGP LCU in terms of an extension to BGP LU, as well as EODN. Okay, so you're seeing that progress as we go forward. Okay, cloud service distribution. This becomes very critical. Now, there's a lot of discussion that's happening today about this as well. The way to think about this is, where do you host your applications? We talked about today there's going to be a set of low latency applications you need to look at. There's going to be a set of applications which require a particular QoE. You'll also have various SLAs that are going to be required by the enterprises that are going to be using your network. How you distribute your cloud, it's already happening. The centralized data center has been distributed out into the various regions. We see that in the States all over the place. Mostly it's been done to push out peering points, especially with the various OTTs. We see a lot of content caching there. We see peering points being pushed out in the network. Now we're also seeing application hosting further out in the network. We talked about a few virtualization points, right, with Cloud RAN, CDD virtualization. We're also seeing from a subscriber awareness perspective, we've already virtualized the EPC. Now we're looking at CUPS models to go distribute the controlled user plane and push those further out in the network as well. We're seeing a lot of RFPs around this for wireline DHE as well. Okay, so the idea around this is, how do you handle these low latency applications? How do you handle these next-gen applications in your network? If you're building a 5G ready IP transport network, this is absolutely critical for you to consider and think through. Here's an example of a next-gen CO with edge cloud capability. In this case, we've taken a lot of the principles we just talked about. Okay, we've actually disaggregated what would be the multi-service edge functionality, and we put in a fabric-based scaled-out fabric in the CO. We virtualized a set of network functions, and frankly, the idea is to be as scalable and agile and as flexible as possible. You might be hosting PNFs, physical network functions, or virtual network functions in these spaces. You also might decide to actually push your edge cloud further out in the network. You might put it on-prem with several enterprises. We're actually seeing this as gaining more and more acceptance as people think through their next set of edge applications they want to deliver to their enterprises. Okay, I'm going to touch upon security really quickly because I'm burning through my time really fast. But really key principles to think through here. Security is functionally changing in terms of how it's evolving. When we see what's happening in security, we're really evolving from a time where we had a bunch of known security threats, which we could analyze and scrub, to a set of what they would call unknown knowns. You basically can figure out a pattern on security threats. Maybe they would be attacking in terms of volume had gone up to hundreds of millions. And you could find out patterns, figure those out, figure out how to block them, push them back down into your infrastructure, to the place we are now where we see billions of security threats. I had one CTO in Europe tell me the amount of attacks on his mobile data center had gone up 400% in the last year. That should be pretty scary to all of us. And he said the variety and the volume of attacks is what surprised him the most. The attacks are coming from multiple different threat vectors. When we talk about enabling MMTC, when we think about enabling URLLC, when you're talking about enterprise SLAs you have to enable, the actual security threat piece is something you have to pay attention to. We're seeing a few different pieces that have to be secured. Besides your actual infrastructure, how do you know your systems haven't been tampered with? How do you know your OS hasn't been modified? Even your bootloaders for that perspective. From an infrastructure perspective, you need to pay attention to what systems you're buying and how they're protected. From an overall network perspective, we have our traditional security gateways. We can think about firewalls from a roaming perspective or internet perspective. So from a solution perspective, you have a set of functions that you use to protect the network as well. What we're finding now is to actually handle and scale with the threat of billions of attacks going across the network and the number of threat surfaces increasing exponentially. We're now leveraging the cloud, compute in the cloud, where we can actually have a much wider view, understand who all the bad actors are, the malicious IP addresses, etc. Use machine learning and AI algorithms, figure out what those problems are, and actually program the infrastructure to block them. So think about this. How do you handle a day zero attack? You have to be able to instantaneously figure out who is attacking your network and where, and you have to reprogram your infrastructure to block those attacks. Okay, so these are the type of things I was talking about when we say AI, ML, etc. This has become more prevalent in terms of using that technology to fix your infrastructure and keep it relevant. These are the things to look at. Okay, last big slide is on automation. Absolutely none of this is possible without proper automation, okay, across the board. And the techniques in automation have to be moved forward as we go. We're pretty much between day zero and day one on this chart from what I see. Most of it's human-driven automation from what we see at most operators. We see a lot of improvement on there as we go forward. We're seeing people using more and more real-time telemetry. So you actually need an infrastructure that's able to stream information off of the various devices in your network, stream that up to higher layer systems that actually can take that information, put it in a data lake, analyze it with various ML algorithms, and say, hey, here's some rule-based information that we can actually push back down and say, if X happens, then Y should be a result. What we see happening as we go forward in there, we're going to keep driving this forward from an ML perspective. I think the algorithms will keep getting better. We have a number of programs already in place with this. Juniper, we have something called HealthBot, which allows us to actually monitor the network in real time, actually figure out what's happening in the network before actually a human operator can figure it out. But we're also finding, and you can see this in any amount of AI and ML research, the most successful algorithms actually require both the ML and AI plus the human experts to make them truly effective. And I think that's the state of the art of where we are right now in terms of using these techniques. Eventually, we'll get to the point where you see on the far right of the side in terms of autonomous networks, where we'll be monitoring the deep learning algorithms, et cetera. But that's, I think, a ways away for us. So I'm going to close this up real quick. I want to thank you for the time today. I think there's a number of things that an operator has to pay attention to today. If you really want to build a next generation Agile IP network for next gen service delivery, there's obviously a host of different topics to deep dive into. I think any one of these can be a multi-day workshop, candidly. But we're very excited to talk to people about this. We'll be outside at the Juniper table next to our strategic partner, Ericsson. And we're really happy to kind of continue the conversation, get your viewpoints and your experiences on how you're building out your networks to go handle 5G and everything it brings. Thank you.